Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart. I'm an architect at Winelect, and today we're going to be talking about 4 things that most networks have. These are the fundamental building blocks that most all networks are going to have to get those networks up and running and connected to the internet so they can start doing their job of transmitting data between hosts on a network. Hi guys, today we're going to be talking a lot more about networking, and we're going to be looking at some of the essential ingredients that are needed to actually build out a network. There are, in my experience, 4 things that are almost every network has to have in order to function. And these 4 things are essential not only for local area networks, but also networks in the cloud. Many of them we almost take for granted when we actually start doing networking, but I do want to review these things so that you're cognitively aware of them when you actually start deploying networks in the cloud and you look for problems areas, or you might need to think about how to get traffic between VMs or subnets or to the public internet for that matter. So with no further ado, let's dive in and talk about the 4 essential ingredients for most networks. Typically, the first thing that a network needs to run is a DNS service or a domain name service. And what this service does is provides the ability to associate names with IP addresses. So for instance, winelect.com gets associated with an IP address online, and that IP address then can be used for routing. Now, a DNS service is not always used on a local area network. Rather, a local area network in a home or small business might just have what they call a DNS forwarder, and it's really just taking those DNS queries and then forwarding those onto a service on the internet. Then that query is returned back to that home and or small business and translated into an IP address. Enterprises almost always certainly will have a DNS service on premise to control the names that are used for services that are running on premise, so that the local traffic doesn't have to go out to something external, or it can be used to associate private IP addresses with services that are running on that enterprise. So the domain name services give a layer of convenience so that you can keep the domain names the same, but have the ability to change IP addresses if needs be, or even associate multiple IP addresses with a given domain name, which for larger domains such as Microsoft.com or Google.com, there might be multiple addresses associated with those. Or on a local network, you might change your IP scheme, or you might get a new server, upgrade an old server, and you don't want to go through and update all of the records for a given service on that enterprise network on all the hosts. So you need a way to quickly swap that out. You can do that with DNS rather quickly. The second thing that most all networks have is something called a DHCP server or DHCP service. Now, DHCP stands for Dynamic Host Control Protocol, and it does exactly what it sounds like it does. It dynamically controls the IP address assignment to hosts on a given network. So on a small network, it might not be a big deal to manage all the IP addresses assigned to devices on that network. If you have just a handful of devices, maybe 6 or 7, you can go into the settings on that given device and update those settings manually. But imagine a network where you literally have thousands and thousands of devices. Doing that would be very hard. So what DHCP does is allows you to centralize the management of that by controlling that from a centralized service. And then whenever a host connects to a network, it will be assigned an address to that host. And DHCP does more than just assign a host address. It also assigns things like DNS IP addresses and things like default routes. Now, because a given host doesn't know exactly where to do queries for DNS, you can't use DNS to look up DNS. You actually need to have the DNS service IP address first before you can do any queries against domain names. So DHCP actually will control the assignment of DNS IP addresses to a host. It also controls, as I mentioned, default routes. So in the most cases on a given local area network, you might have the ability to route to local hosts that are on the same subnet, but anything that's outside of that subnet, most hosts on that network aren't going to know where to send that. So what DHCP will do is assign a default route to that given host, and that's generally speaking the internet gateway for a given network. So everything that's not picked up by a route in a route table will be routed to a default route, and then that will be routed, generally speaking, out to the public internet or to some upstream router on a larger network. Now, on larger networks, a DHCP service will actually integrate with a DNS service, and it does this by updating the DNS service with new IP address assignments for given hosts, so that whenever a host on a network goes to find a given host, such as a particular website or a particular internal server of some kind, it can find that by using a host name, because a DNS server that was updated by a DHCP server, and the address that was assigned to that host was also done by the DHCP server. So the combination of DNS and DHCP on a given network give a very robust management platform for large enterprise class networks, as well as cloud-based networks for that matter. The third thing that most all networks have is something called a router, which we've already mentioned. A router is simply a piece of software device that connects two networks together, and in most cases for a local area network in a home or a small office, that's simply a device that connects the local area network to the public internet. On enterprise networks, though, a router is something that can be used to connect local area networks to other local area networks to form a larger local area networks, and it simply routes traffic between those various networks using private IP addresses. Now, a route that goes out to the public internet will obviously need to use something like network address translation, which we discuss in the video on routing. But in any case, these devices are simply used to connect network segments or networks together, and most networks that are going to be doing any kind of enterprise class workloads or internet bound workloads will need a router of some kind to work. Lastly, the last thing a network needs is actually the physical media, and I almost overlooked this, but the idea that you need a physical media to connect to is primarily the whole reason that networks work. It's the underlying infrastructure that makes all of it happen. And in most of the cases on home networks or small business networks or even enterprise networks, it's Wi-Fi and Ethernet. And these two media are typically responsible for all the local traffic. And then you might connect to some other media like fiber optic or cable or DSL or some kind of switch network that is provided by a telco in order to connect to the public internet. Now, regardless of the actual kind of media that you're using, having a switch is what you need to actually do that hardware switching between the various kinds of media that you need. And a switch is basically just that. It's a piece of hardware. And most switches will have the ability to convert between different kinds of media, whether it be fiber optic or something like Wi-Fi to Ethernet or Ethernet to Wi-Fi or something along those lines. And switches come in all shapes and sizes. Some of them are dedicated, some are more integrated. It just depends on the nature of the actual physical hardware that is being used to build out a network. I have here in my hands my old switch that I used to use on my local area network here, and this is a pretty typical example of what you might find on a small office or home network, and it's an integrated device where it has all the four functions I just mentioned into a single device. Here you can see that I have a Ethernet switch that allows me to switch between various devices that connect by way of Ethernet, and it also has a place to plug in a Wi-Fi antenna, and this device will switch packets between Wi-Fi and the Ethernet without a problem. It also has a port to connect this thing to an upstream router in the event that I want to connect it to the internet by way of Ethernet. But it also has the ability to convert this to coax as well, so this allows me to connect it to both coax and to an Ethernet router upstream of it. So this has a built-in router as well as the ability to do media conversion to different kinds of media like we see here. So this device also has built into it a DNS server and a DHCP server. So it's integrating DHCP, DNS, switching and routing all onto a single device. Now, an enterprise class network won't use an integrated device for all of these things. Rather, like as I mentioned, it's going to have a separate device for DNS or DHCP and use other things like internal switches or other switches to connect to upstream routers or such as that. And I have that kind of infrastructure on my home network, not because I need it, but because I like to play with networks and because I like to learn things and I like to configure things and I like to implement the most secure network I can. I have implemented it in my home, a network that uses a discrete DHCP server, a discrete DNS server. I have multiple switches and also multiple access points. And I also have a discrete router that I use for a router/firewall appliance. Now, in my network, I really have 3 network segments. I have a guest network. I also have a what I call trusted network for all my trusted devices, which includes my laptop, my wife's laptop, phones, tablets, and a couple other things we might use for streaming. A guest network, and then something I call my IoT network, which I use for things like my security system, my HVAC system, and my vacuum robot, and other things like that I can connect to that I don't want talking to my trusted network for that reason. So with a segmented network like this, I can provide a much more robust security platform by segmenting my network and then connecting those things by way of switches and routers and using dynamic host control protocol to manage the assignment of addresses to those various networks. And I can also use DNS to control the actual network itself and then control forwarders that are being forwarded to on the internet. I actually use a third-party DNS for security reasons rather than use the ISP one. So I actually am able to control that flow of traffic by using my own on-premise DNS server, and then I can control the forwarders in that to send it up to a particular DNS server on the internet. I use OpenDNS, and then I have filters set up on that to filter out malicious content or other types of content that I don't want on my network. So all in all, an enterprise network might look something like my home network, but all in all, it's not necessary to have this for every home network or small business network, but you get the idea that you can have everything from a integrated device like I showed you a moment ago to a network where everything is its own discrete unit and they all function together to bring about a network. On the cloud, it's very similar to something like my home network where the integration is all done discreetly, but it's done more at an abstract level, so you really never actually see it. Under the covers on most cloud networks, you have a DHCP server that's controlling your address assignment. There's a DNS service that is actually supplied to your virtual networks that are on the cloud, and it's also going to control your routing and your switching all for you. But all these components are available on the cloud network, and you can control them by way of software-defined networking and the configuration files for building out your network. And we're going to look at some of these various ways to build out these networks in upcoming videos as we discuss networking in the cloud, particularly as it relates to Microsoft Azure. So stay tuned for new videos that will be coming out next time as we wrap up our series here on infrastructure and networking fundamentals, and we transition into infrastructure as a service on Microsoft Azure. If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.